Hello, my name is Tomas Pettit. Today, I would like to represent my AI-assisted programming project, Wardrobe Organizer. And before I'll show you my running application, let me tell you about AI tool demonstration on the re-usage.md file and explain the documentation for what I've through. On the re-usage.md file, this short doc captures how I used AI across the project, tools, prompting techniques, and how I wired MCP into the app for weather-powered outfit suggestions. Sections include tools used, Copilot, ChatGPT, etc., prompting patterns, few-shot, chain of thought, constraint-based, concrete prompt examples with code, challenges, lessons, and a reflection on impact. Highlight: I implemented MCP-style orchestration in the app to merge weather data and fashion logic for daily outfit suggestions. On Section 4, Effective Prompts Examples, let me give you a quick 2 examples for you look at. Example 2, Fast API Daily Suggestions Route. On prompt goal, this is what I put down. As for the result of my project for what has been showing. Why it worked, I specified endpoint behavior, dependencies, and response shape, so AI produced clean, idiomatic fast API code with pedantic models. Example 3, Async Weather Fetch Refactor. On prompt goal, this is what I put down. As for the result of my project for what has been showing. Why it worked, clear constraints, async, timeouts, error handling, yielded production-ready code I could drop in. I used MCP-style orchestration in the app to combine weather context with fashion guidance. Let's go to the GitHub code space in the backend folder of how to MCP works. The handler in protocol.py standardizes contexts, like weather and fashion, and composes results. It could asynchronous router that standardizes processing of small domain contexts. The suggestions router exposes endpoints powered by this MCP layer, debugging and understand. I used MCP-style orchestration in the app to combine weather context with fashion guidance. The handler in protocol.py standardizes contexts, like weather and fashion, and composes results. The suggestions router exposes endpoints powered by this MCP layer. Hit 1 or 2 endpoints in your browser or with curl on backend, app, Reuters, suggestions.py. Returns combine JSON, weather _recommendations, categories plus reasoning, and fashion _guide based on temperature, occasion. Returns weather plus suggested _items pulled from your Superbase wardrobe and a human-readable reasoning string. On Section 6. Impact Reflection. Speed, AI accelerated boilerplate, endpoint wiring, and refactors, roughly 2-3 times faster iteration. I spent more time validating than typing. Quality, prompts nudged clearer typings, consistent error handling, and modular boundaries. The result is easier to read, testable code. Advanced techniques. Few-shot prompting, I supplied existing Reuters schemas so new endpoints matched conventions automatically. Chain of thought, I decomposed weather wardrobe suggestions into tractable steps to validate each layer. Constraint-based prompting, required async, strict error handling, typed models, and response shapes to keep outputs production-ready. MCP in app, a protocol layer, MCP-like, that fuses weather data with fashion guidance. The suggestions endpoints consume it directly for user-facing features. Next, code walkthrough. Highlight areas where you expended most effort. Show integration of AI-generated code. Explain your code architecture and design decisions. Application overview. This is a full-stack wardrobe organizer that combines weather APIs with AI to suggest outfits based on real-time conditions. Authentication. Wardrobe. Add clothing form. Edit clothing form. Outfits. Create outfit form. Edit outfit form. Suggestions. And that's the application overview. MCP integration demo. Back to the backend folder, app, MCP, Reuters.py. The MCP protocol handler standardizes how we connect weather and fashion APIs. It provides type-safe resource handling and combines multiple API responses into one unified suggestion. This allows me to Enter a city in the Suggestions page. Show weather fetching in real time. Display the AI reasoning combining weather plus wardrobe. The MCP protocol handler standardizes how we connect weather and fashion APIs. It provides type-safe resource handling and combines multiple API responses into one unified suggestion. Database architecture. The database uses a many-to-many relationship allowing flexible outfit combinations. Season-aware filtering ensures suggestions match the weather. This statement creates a junction table named outfit_clothes to model a many-to-many relationship between outfits and clothes. Each row links one outfit to one clothing item, and a single outfit or clothing item can appear in many rows. Live feature demo. Let me give you an example on the application. Add a blue hoodie, select winter and add a blue for the name of the color, and wait until it comes up, added on the clothing list that has been showing. You can even add a description or image URL link, whatever you want to do to make it even far improvement. You can update the clothing in case you made up your mind whatever you do or don't like that clothing. Go to Suggestions, enter Reykjavik, cold city, see winter items suggested and change to Dubai, hot city, see summer items suggested. The suggestion engine filters by season based on temperature. If I request suggestions for a cold city, it prioritizes winter items. For hot cities, summer clothing. AI integration points. I've split the screen into two parts. One part is the re-usage.md, scrolling to the prompting techniques applied, and the other part is weather_service.py, temperature to season logic, and API.ts, GitHub Codespaces URL resolution. AI helped scaffold the weather service and React components, but I manually designed the MCP protocol and integration logic. The Codespaces URL resolution was particularly challenging. Code quality and architecture. On the front-end and back-end folder. Main.py that would allow to get the connections of the for Reuters. And while for data suggestions.tsx that can enter the name of the city. The architecture prioritizes separation of concerns. Reuters handle HTTP, services contain business logic, and the MCP layer abstracts external APIs. Full type safety with Pydantic and TypeScript. Now let's go to the application that I had both front and back end up and running. And tell how it works for wardrobe organizer application, e.g. components, contexts, etc. On the front end, src app.tsx for what I've done for my project. Render content method is for navigation page. Is authenticated variable is if your user account has already logged in or not using Superbase as bars. I'll sign in with a demo account. Authentication is handled on the front end via our auth context and Superbase client, so the UI reacts instantly to the session state. Once I'm logged in, actions like adding clothes or creating outfits become available because I'm using Superbase. Here's my wardrobe. I'll add a new item, blue hoodie, category, top, suitable for cold weather. When I save, the item appears in the list immediately. This goes through our API client to the fast API clothes route, which persists it in our database. Now let's check out the front end, API.ts, and back end, Reuters, clothes.py, for what I did. Now I'll build an outfit. I'll call it Cozy Winter Fit and include the hoodie plus jeans. After saving, it shows up here. Outfits are just compositions of clothing items. The backend validates the item IDs and returns the created outfit. That's the Python codes of router outfit and the number of interface outfit, create, update, suggestions using weather data. Let's pull the current weather. I'll search for a city. The backend service normalizes the API response so the UI can display temperature and conditions consistently. This weather powers our suggestions. And here's my Python codes of weather router and weather service for getting access to the weather API. Now I'll generate today's outfit suggestions. The backend combines my wardrobe with the current weather to pick suitable items, prioritizing things tagged for these conditions. Here you can see the suggested combination for the day. Let's wrap it up. Sign in, manage clothes, create outfits, view weather, and get personalized daily suggestions. The stack is TypeScript React on the front end and Fast API on the back end, with clean schemas and routes. And thank you for watching this video for what did for my AI-assisted programming project, Wardrobe Organizer.